Okay, so once we have our time, we use our delta dx equation. Sorry, that looks blurry. So delta dx will be equal to vi cos theta delta t. So delta dx is equal to, it was 80 meters per second cos of 40 times the time we just found, 11.37958 seconds. So times 80 times the cos of 40, and we get delta dx to be 697.38 meters. Okay? Alright, so then the last part wants the VF. So to find the VF, we need both the VFX and the VFY. VFX should be easy. VFX is just equal to VIX. So it's equal to 80 meters per second cos of 40, which is what we just did. And so VFX is equal to 61.2836 meters per second. So that's our VFX. Now we need our VFY. So you can get your VFY by doing, if you want, VFY squared is equal to VIY squared plus 2AY delta dy. And I'd go this route perhaps because that way if you screwed up your time, you were given all these. Okay, so VFY squared is equal to, this is 80 meters per second sine of 40 squared plus 2 negative 9.81 meters per second squared, and then delta d is negative 50. Okay, so you still have to look after your positives and negatives. So this squared is 2644.3258, etc. meters per second. Negative and negative will be positive. 109.81, 109.81. And these numbers perhaps should look familiar to you. When you add these together, you get 3625.3258. And when I said these should look familiar to you, look, it's exactly this. What's under the radical is your VFY. So if you've already done all this, if you've done your quadratic to find your time, this number right here will be your VFY. Okay, so you don't have to redo it all again. If you've done this and if you've done the quadratic and then I ask you for this, I'm okay if you say VFY is equal to 60.21 meters per second and then just write under radical. It's also called the discriminant. Once you have those two, then you just do, right, this one was 61.2836 meters per second. This one was 60.21 meters per second. I'm going to square them, add them together. Oops, except I drew it the wrong way. Take that back. So do this and do this. Okay, so this one is your 61 point whatever it was, 2836 meters per second. And this one is your 60.21 meters per second. Square them, add them together, take the square root, and get your VF and your theta. Okay? Sorry about that. I was thinking we were doing VI like the last one. And you should get what's listed on this sheet, something like 85.91. And obviously with these two numbers so close to each other, it's going to be really close to 45, just a little bit less. So 44.49. Okay? So let's move to the textbook, and let's go to page 543. And we might have enough time. Let's do number 12, okay? Because I think we might have enough time for that. So large insects such as lotuses can jump as far as 75 centimeters horizontally on a level surface. All right. And so it's telling us that our delta dx is 75 centimeters, or 0.75 meters. It says that their launch angle is 55 degrees, I think. Yeah, and it wants to know what was the initial speed. Okay, so x direction, VIX, VI cos theta, AX 0, delta dx 0.75 meters. Y direction, VIY, VI sine theta, AY 9.81 meters per second squared, and this is down, this is up, this is down. And so we can start in the y direction with our up, and we can do AY equals VFY minus VIY over delta TU. This goes to 0. And so delta TU will be negative VI sine theta over AY, but we can't find it because we have two unknowns. But delta T total will be equal to negative 2 VI sine theta over AY. So then if we go to our x direction, delta dx is equal to VIX delta T, 1/2 AX delta T squared. This goes to 0. Delta dx will be equal to VI cos theta delta T. So two equations, two unknowns. If we take our delta T and sub it in here, I'm just going to move it over to this side. So we will have delta dx is equal to VI cos theta, and instead of delta T, we're going to write negative 2 VI sine theta over AY. Okay, so take your negative and AY over. Negative AY delta dx. V to I times VI is VI squared. And then you'll have 2 sine theta cos theta. So this is that trig identity again that we were using last week. So this is the same as having negative AY delta dx is equal to VI squared times sine 2 theta. Now technically you don't really need to use it here because you know your thetas. So you could leave it as sine 2 sine 55 cos 55. But hey, a good motto is to have never lose an opportunity to use a trig identity. This time we're solving for VI squared. So VI squared will be equal to negative AY delta dx over sine 2 theta. And so VI squared will be equal to negative 9.81 meters per second squared, 0.75 meters. And on the bottom, sine, and in brackets, 2 times 55. VI squared equals, so negative will be positive, 9.81 times 0.75. So on the top you get, not 0, sorry, 7.3575. And that will be meters squared per second squared. And you're going to divide that by 110 sine. On the bottom, 0.939693, etc. So this is 7.829688 meters squared per second squared. Take the square root. And you get 2.798 meters per second for your grasshopper / locust. Of course, my question is, who the heck thought of checking to see how fast grasshopper could hop and why? Because, like, how long would you have to be lying awake at night to say, I'm going to take a camera and lie in the grass and take this picture? And then how long do you have to lie in the grass? All right, so there's number 12. I'll come back with the others in another video.